All right, today's lesson is called segment proofs. We're going to do some more proofs. We're going to prove segment lengths that are congruent to each other, basically, here. Some stuff from your algebraic proofs. We have all the properties that we went through when we were solving those things. We didn't talk a whole lot about these last three here, but with the segment proofs, we're going to use all three of those a lot today, especially your transitive property. All right, here we go. The properties of may only be used with equal signs. The following properties of congruence can be applied to statements with congruent symbols. Remember, your symbol for congruence is that equal sign with a little squiggle above it. All right, we use that when we're talking about measurements, basically. All right, properties of congruence. The reflexive property, this one will look the same. We just have to use congruent signs with them. For any segment AB, we can say that AB is congruent to segment AB. Remember, reflexive, same on both sides. Same on both sides. Symmetric property, remember, this is the one where we flip. Example, if AB is congruent to segment CD, then I can say, just flip it, segment CD is congruent to segment AB. Transitive property, if AB is congruent to segment CD and segment CD is congruent to segment EF, then I can say segment AB is congruent to segment EF. And throughout the lesson, guys, I'm going to number these things. This, I believe, will help you see it a little bit easier. If 1 is congruent to 2 and 2 is congruent to 3, then I can say 1 is congruent to 3. So if you want, try to have a couple of colors with you. It might help you guys out today a little bit. All right, definition of congruence. Segments are congruent if and only if they have the same measure. All right, so basically it does this. If segment AB is congruent to segment CD, then I can say, since the measurements are the same, they are now going to be equal. AB is equal to CD. They just went from a congruent sign to an equal sign. And then vice versa. If AB is equal to CD, I can say that segment AB is congruent to segment CD. And they just went from equal sign to congruent sign. That's your definition of congruence. Definition of midpoint. The midpoint of a segment divides a segment into two equal parts, congruent parts. If M is the midpoint of AB, then I know that AM is equal to MB. A little visual for you. If M is the middle between A and B, then I know that this piece is equal to that piece. Definition of a midpoint. It creates two equal parts. Last one, segment addition postulate. If A, B, C are collinear, remember collinear means points on the same line, and B is between A and C, then I can say this. If I take AB, this piece right here, and add that with the back end piece, BC, so that this piece plus that piece has to equal the whole thing, A to C. That is your segment addition postulate. Small piece plus small piece equals big piece. This next page is checking to see if you know the properties, and once you know properties, then we can apply them to the proofs in the next 2 or 3 pages. Here we go. First one, they went from equal sign to congruent sign. That's your definition of congruence. And I'm going to notate, instead of writing out definition of congruence, def stands for definition, and this is my symbol for congruence, definition of congruence. Number 2, If K is between J and L, then JK plus KL equals JL. That's the last one we just talked about, guys. Small piece plus small piece equals big piece. Segment, addition, postulate. I'm just abbreviating. Same on both sides. That's reflexive property. Number 4, if RS equals TU, then RS plus XY equals TU plus XY. They're adding this to both sides. That's your addition property. This one, they just flipped it at number 5. When you flip it, that's our symmetric property. Number 6, if Y is a midpoint of XY, then XY equals YZ. That is your definition of a midpoint. If you ever see this word in your questions or on the homework or on a quiz, 9 times out of 10, the reason is going to be definition of a midpoint. All right, get your colors out. Number 7, I'm going to call FG1, HI2, and JK3. And instead of reading out the segments, I'm just going to say this. If 1 is congruent to 2 and 2 is congruent to 3, then I can say 1 is congruent to 3. That is your transitive property. We will use that one a lot today. I promise you'll understand that one by the time the notes are done. If not, rewatch it. Number 8, AB plus CD equals EF plus CD. Then I can say this. Well, the question is, all right, if I look at the left-hand side, I see I'm adding CD to both sides, right? But to get from this side to this side, I had to subtract the CDs away. So this would be your subtraction property. Number 9, if PQ plus RS is TV and RS is equal to WX, I can now replace RS with WX. Whenever we replace something, we call that the substitution property. I replaced RS with WX, substitution property. Number 10, LP is equal to PN, and LPN are collinear. Then P is the midpoint. Small piece plus small piece equals the big piece. That's your definition of midpoint. Number 11, they're going from congruent sign to equal sign. Definition of congruence. Number 12, CD plus DE equals CE. And basically, they just subtracted over DE. If you check it out, they just subtracted DE to the other side, subtraction property. All right, let's get into the proofs. This page right here, guys, these are just the reasons to answer your questions, guys. So it's in your notes. If you need them, you can kind of print this out and have along as you're doing the notes. It's up to you, but it's just an answer page for you guys. All right, here we go. Segment proofs. Complete the proofs below by giving the missing statements and reasons. This page, they just want all the reasons from us. All right, given E is a midpoint of DF, we got to prove that if I double DE, that equals DF. Okay, first reason, always given. Okay. From line 1 to 2, well, if I know E is a midpoint, hint, 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 of DF, then I can say that DE is equal to EF, definition of midpoints. That creates two equal pieces. From line 2 to 3, well, what are they doing to both sides here? Well, they're adding DE to both sides. So from line 2 to 3, they added DE to both sides. That's addition property. From line 3 to 4, well, this side stayed the same, but over here, they combine like terms. DE plus DE equals 2DE. So they just combine the two DEs. When I replace or combine, that is your substitution property. Number 5, DE, check up here, DE plus EF equals DF. Small piece plus small piece equals the big piece. That is your segment addition property. Okay, here's a tricky one now. I always like to work backwards for transitive property. Okay, I'm going to call it 2DE a 1, the DF a 3. Now, you have to go back up into your statements to kind of follow the pattern here. So if I'm looking for this, DF is still a 3. DE plus EF is my 2. And 2DE is my 1. Check this out now. Here's why it's transitive property down here. I'll fill this in for you. If 1 equals 2 and 2 equals 3, then I can say 1 equals 3. Transitive property, guys. We are going to have a lot of transitive property. That was the first one, probably a little scary. That's fine. We have a bunch more of these to get through. Number 2. In this case, we have two givens. KL is congruent to LN, and LM is congruent to LN. They put both of those in the first statement. That's our given. Okay, from line 1 to 2, what's going on here? Well, the only thing that changed is they went from congruent sign to equal sign. That is your definition of congruence. Number 3, KL is equal to LM. Oh boy, here we go. Check this out. Let's work backwards again. Let's call KL the 1. We'll do LN the 2. LN's a 2. LM's a 3. Line 3, hey, KL is still a 1. LM is still a 3. If 1 equals 2 and 2 equals 3, then I can say 1 equals 3. That is your transitive property. And last one, hey, KL is equal to LM, so that must mean that L is a midpoint. If this piece is the same as this piece, then L has to be the midpoint of that. Once again, if you ever see this word, kind of a little hint, it's going to be definition of midpoint. Not always, but 99.9% of the time. That one's done. Number 3, we have two givens. PQ is congruent to TQ. UQ is congruent to QS, and they both are right there. First reason is always given to us. All right, from line 1 to 2, they just change your congruent sign to an equal sign. Definition of congruence. From line 2 to 3, all right, what's going on here? Looks like we're adding up some segments, right? So let's check out the diagram. PQ plus QS equals PS. Okay. TQ plus QU equals TU. Small piece plus small piece equals big piece, and same thing for that guy. That is your segment addition postulate. You're adding up two small pieces to get the big piece. Number 4. Now, this one may look like segment addition, but it's not. Check it out. If I take TQ plus QS, does that equal PS? Okay, so I can't be segment addition. So now what do I know? All right, I know this. I know that PQ is equal to TQ. So what they did was this, guys. They replaced PQ with TQ right there. I replaced it. So I took this equation right here, and I just replaced PQ with TQ. That's our substitution property, not segment addition. Now, once again, number 5, man, is this segment addition? Check out the diagram. TQ plus QS equals TU. Well, that doesn't work. It can't be segment addition. But what is it? Oh, it's substitution. I replaced right here, this equation right here, I'm replacing QU with QS. So I replaced QU with QS. I kind of sneak it in here. I just replaced. So once again, substitution property. So over there, just replaced it. That's all we did. Number 6. All right, I'm going to give you the reason, and I'll show you how I got transitive property. All right, back up top here. Look at line 4. Let's call PS the 1, TQ plus QS a 2. Go down another line. TQ plus QS is still a 2. TU is a 3. PS is the 1. TU is a 3. If 1 equals 2, 2 equals 3, then I can say 1 equals 3. That is your transitive property. Last one, they went from equal sign to congruent sign. Definition of congruence. Next page. All right, let's see, we've got 3 givens this time. K is the midpoint of JL, M is the midpoint of LN, JK equals MN. All right, so the first reason is given, but I also have number 3 is also given to us. So I had 3 givens up here, 1 there, 1 there, and I had 1 there, right? They're all taken care of now. All right, here we go. There's that keyword again, midpoint, right? It says K is a midpoint of JL, and M is a midpoint of LN, which would mean then this piece is equal to this piece, and then that piece is equal to that piece, right? Definition of midpoint. Line 3 to 4. I know that's stating that MN is equal to KL and LM is equal to MN. They're substituting here, guys. JK is equal to MN. So basically, I replaced JK with MN. Right here, I just replaced JK with MN. That is substitution property. All right, 5's a tricky one. Let me give it to you. It's transitive property. Let's go back to the proof and try to find it. Let's call KL the 1. MN is your 2. MN is your 2. LM is your 3. LM is my 3. KL is my 1. Check it out. If 1 equals 2 and 2 equals 3, then I can say 1 equals 3. Transitive property. This is so sneaky, but hopefully it's kind of setting in a little bit here. All right, number 6. KL is equal to LM. So from line 5 to 6, they just did this, guys. They just flipped it. From line 5 to 6, they flipped. That is your symmetric property. And line 6 to 7, they replace the equal sign with congruent sign. Definition of congruence. Number 5. I have 2 givens. XY is congruent to UV. YZ is congruent to TU. They are both in the first statement. That reason is given. Line 1 to 2, congruent sign to equal sign, definition of congruence. Number 3, okay, it looks like segment addition, but I gotta check the diagram to make sure it's small piece plus small piece equals big piece for both of these. Let's check it out. XY plus YZ equals XZ. Yep, segment addition. TU plus UV equals TV. Yep, segment addition. Always check the diagram if you see segments being added up to make sure it's segment addition postulate. All right, we got some substitution going on here, guys. The first equation, they replaced XY with UV. I told us it right there. And over here, I'm replacing TU with YZ. I replace these two segments with those segments right there. Substitution property. And you guessed it, transitive property. All right, let's go back up a number, see if it works out. All right, let's call XZ a 1. This addition, XY plus YZ a 2. Here we go. Let's see. YZ plus UV is still the 2. TV is our 3. XZ is still my 1. And TV is my 3. Sure. If 1 equals 2 and 2 equals 3, then I can say 1 equals 3. Transitive property. Last one, they went from equal sign to congruent sign. Definition of congruence. Number 6, two givens. YW is congruent to YZ. XZ is congruent to VY. First reason, those are given. All right, here we go. Congruent sign to equal sign. Definition of congruence. All right, 3. This looks like segment addition, but I got to make sure by looking at the diagram. Do these two pieces add up to give me the whole piece? XY plus YZ equals XZ. Yes, segment addition postulate. Okay, 4. Is that segment addition? Check with the diagram. VY plus YW equals XZ. Well, that's not segment addition. However, they replaced in this one, they replaced XY with VY. They replaced YZ with WY. So that one was not segment addition, that was substitution. They replaced two pieces with those two pieces. Substitution property. Number 5, okay, hey, these are segments being added up. Is it segment addition? Check with the diagram. VY plus YW equals VW. Yep, you bet. Segment addition postulate. Okay, and 6 is transitive. Let me show you how I got that for my reason. Let's go back up top. Let's call XZ a 1. VY plus YW is a 2. Next line down. That same stuff is a 2. VW is my 3. XZ is my 1. VW is my 3. If 1 equals 2 and 2 equals 3, then I can say 1 equals 3, transitive property. Last reason, equal sign to congruent sign, definition of congruence. Next page, number 7. This time we got to fill in some statements as well now, too. All right, we have 2 givens. First reason is always given to us. Okay, it says E is a midpoint of AC, right? If E is a midpoint of AC, then I know that this piece has to be congruent to that piece. And I say that in my next statement, right? AE is equal to EC. Reason, definition of a midpoint. Number 3, hey, it was given to us. Well, what did I not use yet? I did not use this given right here. So put that in for number 3. DE is equal to EC. Okay, so far so good. But now it's saying AE is equal to DE. Yep, you bet. Here's why. We'll call this piece the 1, that piece the 2. EC is still a 2. We'll call DE a 3. And sure enough, there it is. If 1 equals 2 and 2 equals 3, then I can say that 1 equals 3, transitive property. Okay, reason, definition of congruence. That means I either go from congruent sign to equal sign or vice versa. In that case, they want you to change up the equal sign to congruent sign. So now segment AE is congruent to segment DE. Equal sign to congruent sign. From line 5 to 6, they just flipped it. Symmetric property. They just switched those two with that one. They just flipped it. That's all they did. Number 8. Just have one given. There it is. All right, this is an old reason. What are they doing to both sides here? Well, from line 1 to 2, they're multiplying both sides by 2. 2 times that is that. 2 times that is that. Multiplication property. Okay, the reason is segment addition. Well, if I look at the diagram, I can only add this piece plus that piece to get the whole thing. So let's say that in equation. RS plus ST equals the whole thing RT. All right, line 3 to 4 here. Well, it tells us that 2RS is equal to RT. So what they did was they replaced RT with 2SR, right? I'm replacing RT with 2SR. That's the only difference from this line to that line. I'm just replacing. That's our substitution property. Okay, tricky one. From line 4 to 5, what are they doing on both sides here? Well, here's what they did. They subtracted an RS from both sides. That is your subtraction property, kind of sneaky. But they subtracted RS from both sides to get here. Okay, last reason. Little clue for you. Whatever you're trying to prove always goes in your last statement, right? The clue was, or the reason was definition of midpoints. All right, well, check out the diagram. This would have to mean that S has to be the midpoint of RT. Hey, sure does enough right there too. S is midpoint of RT. Number 9. Let's see, I got 2 givens, right? M is the midpoint of Ln. That was given. Hey, here's my other given. So I got to put the second given into the statement that needs it right here. N is midpoint of MO. All right. So if I check out going through this now, it says that M is the midpoint of Ln, so that this piece is congruent to that piece. N is a midpoint of MO, so that would mean Mn is equal to NO. That is, once again, your definition of midpoint. Like I said, guys, if you ever see this in a previous statement, the reason is most likely to be definition of midpoint for your next reason. All right, transitive property. Oh boy, here we go. We got this. Let's call Lm a 1, Mn the 2. Mn is your 2. NO is your 3. So if 1 equals 2 and 2 equals 3, then I can say 1 LM is equal to 3 NO. There's your 1. There's your 3. Last one, definition of congruence. That means flip this equal sign to a congruent sign. So segment LM is now congruent to segment NO. One more page. This time, no statements, no reasons. We got to fill them out. 3 of these, and then we're all done. All right, first statement, that's our given. Y is midpoint of X, Z. Reason, given. Now let's talk more about that. If Y is a midpoint of XZ, then I know that this piece is equal to that piece, and now we say that. XY is equal to YZ. Reason, definition of midpoints. Right there was a word right there. That's your clue. Okay, what else we got going on here? Number 3. What's the number of these? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, next. Number 3. What else can I say here? Well, I know this. If I were to take this piece plus itself, it could equal this piece plus that piece. Now I'm trying to get this over here, right? So I'm trying to get some math involved here. So let me give this to you. If I take xy plus xy, that will equal xy plus yz, right? If I double this, it's going to equal this piece plus that piece. Okay. Next step, I'm going to, this is your addition property, sorry. Why? Because I'm adding xy to both sides here, addition property. Now I'm going to simplify. I'm going to combine these two pieces right here. Xy plus xy is 2xy. When I combine like terms or replace, that is my substitution property. Number 5, if I take xy plus yz, that is going to give me the whole piece, x to z, segment addition postulate. So if I take xy plus yz, that'll give me the whole piece, xz. All right, here comes the sneaky one. And we call that segment addition, sorry, I forgot that, segment addition postulate. All right, next comes transitive property, and I'll show you where it comes from. If I call 2xy the 1, xy plus yz the 2, and there's the 2 again, and I call my xz the 3, if 1 equals 2 and 2 equals 3, then I can say 1 equals 3, 2xy equals xz, and we'll number them for you, and that is your transitive property. All right, what I'm trying to prove is always goes into my last statements. Xy equals 1/2 xz. Well, what do they do to both sides here? If you go from line 6 to 7, they divided both sides by 2. That's your division property. Tough. Number 11. I have 2 givens, and I'm going to put both of those in the same exact spot here. AC is congruent to DF, and the reason is given. We got the other one. BC congruent to DE. There we go. Both in there. All right, let's label these 1, 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6, 7, and 8. Okay. Let's go to work here. My first step, guys, I am going to take my congruent sign and change it to an equal sign. So AC is equal to DF, and BC is equal to DE. I just went from congruent sign to equal sign. That's definition of congruence. Number 3, I'm going to do some segment addition here. Small piece plus small piece equals big piece. AB plus BC equals AC. Segment addition postulate. And I'm going to do the same thing for the other line segment as well. I'm going to say DE plus EF equals DF. Segment addition postulate. Okay, line 5. Now I'm going to do some replacing here. I am going to replace BC with DE. So I'm going to replace BC with DE right here. So when I do that, I'll have AB plus DE equals DF. So replace BC with DE. All right, so I am going to have AB plus DE, that's how I'm replacing, equals DF. So here, let's just kind of show you what I did here. I replaced BC with DE. And I also replaced AC with DF. I already took my substitution for these two pieces and I plugged them in over here. Substitution property. Okay, line 6, you guessed it. Transitive property. All right, I'll show you how I got here. So let me write down the answer and then I'll show you how I got here. DE plus EF equals AB plus DE. All right, let's number it. DE plus EF is a 1. DF is a 2. DF is a 2. AB plus DE is my 3. DE plus EF is still my 1. And AB plus DE is my 3. If 1 equals 2 and 2 equals 3, then 1 equals 3, transitive property. All right, remember, my goal is still to get this guy right here. AB equal congruent to EF, right? Well, if I look at line 6, both sides have a DE. I can get rid of those. I can subtract DE from both of those pieces right there. So I'm going to subtract off those DEs, which would leave me with EF equals AB. And that was my subtraction property. I subtracted off the DEs. And if I just want to, remember, I'm trying to get to here, right? So first step, I got to flip these guys. AB equals EF, that's your symmetric property. And then they need a congruent sign, right? So I should add a number 9 to this one. Segment AB is congruent to segment EF definition of congruence. Tough one. Last one. Let's see here. Number 12, I only have one given. That goes in the first statement. Let's number them again. 1, 2, 3, 4, 5, 6, 7, 8. 5, 6, 7, 8. All right. First statement, AB, segment AB is congruent to segment CD, given. Let's get rid of that congruent sign, go to an equal sign. AB equals CD. Definition of congruence. Okay, now what can we do here? Let's do some segment additions, right? This piece plus that piece equals that whole thing. And then I can say AB plus BD equals the whole thing over there. So let's work with this little piece here, then work with the whole thing. So first one, let's say that AC plus CD equals the whole thing. AC plus CD equals AD.
Sure, let's kick things off with Start Me Up. By the
Old Siri would like to pick up while we're doing notes, huh? Segment addition. Let's do another piece. AB plus BD equals the whole thing AD. There's a reason to my madness here, I promise. AB plus BD equals AD. Once again, segment addition. Okay, let's do some replacing now, right? I know that AB is equal to CD. So I'm going to replace AB with CD. So I can say, I'm replacing here, AB with CD. CD plus BD equals AD. And I did substitution there. I just replaced. I replaced AB with CD. Okay, just right here, I replaced AB with CD. That's all I did. Next up, transitive property. I'll show you how I got it. It's going to be AC plus CD equals CD plus BD. All right. Let's go back up a couple lines here. AC plus CD, let's call that the 1. AD is the 2. CD plus BD will be my 3. AD is still the 2. AC plus CD is the 1. CD plus BD is my 3. If 1 equals 2 and 2 equals 3, then I can say 1 equals 3. Transitive property. All right. What can I get rid of on both sides of this equation here? They both have a CD. I can subtract off that CD on both sides here. That'll leave me with AC equals BD, subtraction property. And last one, I just got to get it to a congruent sign. Segment AC is now congruent to segment BD. Definition of congruence. That is it for segment proofs.